Hi everyone. Now I am going to discuss about the how to find out the moment of inertia of fractal objects. Okay. Earlier I have given these three questions. We can go through this. A rod, some mass is removed from the rod, like one third of the mass is removed from the rod. 1/9 of area is removed from the square plate, and last one is 1/4 of area of triangle is removed from the triangle. Okay, that I am going to discuss now. Look here, as per the question, we need to calculate the moment of inertia of the this given fractal body. For this I am giving, I hope everyone studied the question. Okay, one third is removed, middle one third is removed, it is continued, so on forever. Okay, now we are going to calculate this. Observe this carefully. I am taking this as a one rod. Rod mass is m, length is l. This rod, I am making this rod into three parts. We can see center part is, let us consider the O. The moment of inertia of this body, I don't know that, that's why I'm taking k into ml square. Okay, moment of inertia of the middle part, middle one third is removed. No, this is one third is removed. Okay, that removed one third body about the center point O is k into ml square. Next, I am taking the another rod, a symmetrical rod, having mass is 3m, length is 3l. Now, if I remove the mass from this rod, I am taking here, this is my thing. Let us consider this is the point O. Now, my new mass is 2m, as L length of the rod is removed here. We can see this is ml, this mass also m, length is L. And total length of the rod is not changed, that is length of this end points is how much? 3l. Now, if I want to write the moment of inertia, I can write as k times the total mass is 2m into length is 3l square. Length is 3l square. I am writing 3l square. So now I will get like a 9 into 2, 18 k m l square. I can write this is 18 times I. Now, the same rod, whatever rod is there, no, that rod I am making like this. You can observe this carefully. I am making this as a rod, center point O. This I can treat it as, you observe this carefully. Here some part is removed. This m comma l, one third is removed. One third removed. Similarly, m comma l, one third is removed. One third is removed. Now I can write this as like this. This is my point O. Again I can write like this. Okay, we can treat same thing as 2 times the point O is here, like this. Here this length is equal to much? L, mass is m, total mass earlier. This rod is that I am taking. Okay, this is similar to this line. Okay, now you can see from this line, this distance is equal to, you know that this gap is equal to L by 2. Here also L by 2 gap. This is also L by 2. Total distance is equal to D is equal to much? L only. Okay, now you can see that the moment of inertia of this I am taking as, why? Because earlier whatever 3m and 2l rod is there, no, middle part is removed, it becomes 2m comma 3l rod. Okay, the 2m comma 3l rod about O can be written as 2 times the one end O, and there is a one fractal object I have taken of that. This I am taking as 2i dash. Now, what is I dash? I dash is the moment of inertia of this body, fractal object, about point O. So this is the point O, okay, about point O. Okay, now 2I dash I have written. This 2I dash also equal to, I can write the value, earlier I got the 89, no? So I am writing this 18I. So from this I got like a I dash value is equal to 9I. I calculated the moment of inertia of the fractal object about point O. Now I am going to take the one more situation. You observe this carefully. This is the fractal object having mass m and length L. Rod is there. No, if rod is completely is there, middle part is removed. No, that point I am taking. O. This distance is L. L by 2. This distance is L by 2. Total distance is equal to how much? D is equal to L. About that point I am writing. See here, kindly observe this. This can be written as from parallel axis theorem. Parallel axis theorem. I can write the moment of inertia of this is about O is I dash is equal to moment of inertia of the fractal object. So here this one plus m into d square. I dash is equal to, already I have considered this is I is equal to k into ml square, m into l square. I got the I dash value is 9I. I am writing here 9I is equal to I plus m into l square. So finally I will get the 8I is equal to ml square. I value is equal to much ml square divided by the 8. This is the answer for this fractal object. Okay, you observe this carefully. I got the value is this one. Okay, similarly second one again I am taking, there is a one square plate is there. This square plate having mass is m, side is L. Having mass m and side L. If I remove some part of the mass, how much mass I am removing here? Let us consider this area, 1/9 area is removed. No, if it is removed, 1/9 area is removed. In that case, for the same length L and mass m, some part is removed. No, that one. So now I am considering the moment of inertia about this is k into m into L square. For remove fractal object I am taking. Okay. Now for symmetry, what I am taking is, this time I am taking very big square plate. This square plate, I am treating this square plate as a combination of the certain square plates. You can see here, this I am taking this as 9 square plates. Okay, this is having 9m is the mass, 3l is the length. Okay, I have not removed anything, just observe that 9m and 3l. From this I am removing the middle part. Let us consider this bigger square plate. Now if I remove the middle part, it is removed. Okay, if I remove this, remaining you can see 8 square plates are there. Each are having mass m, so you can write 8m. Length is 3, side is 3l. Now the new moment of inertia you can write it as k times the 8m into 3l whole square. Now you can write 9 into 8, 72 I will get. Okay. Now the same thing I can treat this as, here this is the center point. I can remove this part here. I can remove from here one square. Here I can remove the 1/9 of area. Square is nothing but 1/9 of area. Here 1/9 of area, 1/9 of area, 1/9 of area, 1/9 of area I can remove. This distance is equal to a by 2. This distance also you can write as a by 2. Similarly, from here, if I calculate the distance, this is a by root 2, this is also a by root 2. So total value I will get the root 2a. I am treating this one, how I am writing here. I can take this as, there are the 4 square plates. Now see here, 1, okay, I am writing here, 1, here there is a 2, this is a 1, 2, 3, not 3, see, this is 2, this is 3, and down one is 4. Okay, that 4 parts I'm writing, that 4 times there is a point O which is located from center to center is how much here? A. Plus one more thing, you can see there are the another 4 is there corners, 1, 2, 3, 4. There are the 4 fractal triangles are there, that 4 fractal square plates are there, no, that I am taking fractal square plates at a distance. This is my O, this is located at a distance of root 2a, like this 4 are there. Okay, from parallel axis, let us consider this is 4 into moment of inertia about this is I1. Okay, similarly plus 4 into moment of inertia about this point O for the second fractal object is 4I2. Now from the above relation you can say that this moment of inertia 72I is there, no, that is equal to the 4I1 plus 4I2. Okay, now you observe this carefully. I don't know what is the moment of inertia for this fractal object about this point O. I am using parallel axis theorem. Parallel axis theorem. If I apply the parallel axis theorem from here to here, as I have the distance is equal to I, now I1 can be written as moment of inertia for this fractal object I plus m into a square. This I1 value already you can write it as how much I1, I don't know I1 value. Similarly, next one, if you see that fractal object like a square at a distance root 2a, about O I am writing again I2 is equal to I plus m into root 2a whole square. From this you can write I plus root 2a whole square value can be written as 2 into ma square, that is my I2. Okay, now you can equate this relation 72I is that I am writing here. 72I is equal to 4. I1 value is I plus ma square. I plus ma square plus 4 times the I plus 2 into ma square. Okay, you can observe that 72I is equal to 4I plus 4 ma square plus 4I plus 8 ma square. Now 4I plus 4I 8, so you can write 72I minus 8I is equal to 12 ma square. 72 minus 8 is 64. I is equal to 12 into ma square. Now fourth table, if you write this will be cancelling 3 times, this will be 16 times. So finally I can write the I value is equal to 3 ma square divided by the 16. This is my moment of inertia of the fractal object. Observe this carefully how I calculated. I am following every time same process. Okay, now last one, you observe again. I am taking a triangle. This triangle having mass is m, length is l, side is l. Okay, side is l. Now from this triangle, if I remove the small triangle like this, I have removed a small triangle. Now the side is same side is there, but mass is obviously it will change. I am taking this kind of object about the point O is this is the removed part. Okay, removed part. I am taking I is equal to k into m l square is. Okay, to do this I am taking a big triangle. Okay, this big triangle having mass is 4m. Why? Because I am making this into the certain triangles. Okay, 4 triangles. Mass is 4m, side is 2l. Okay, this is mass m, second one is second mass, third one is mass, fourth one also mass. Okay, from this I am removing the triangles. You can see it, I am removing the triangle. So removed part I am writing with red color. You can see I have removed the red color triangle. If I remove the red color triangle, I will have only 3m mass, side is 12. This is removed. Okay, now I can write the new moment of inertia of this body is k times the 3m into 2l whole square. So 4 into 3 is 12, 12k into ml square. I will get the 12 into I. That is now my new moment of inertia. Now the same thing, whatever the value is, from every center, as earlier also I have given the distance between them, as it is L by root 3, everywhere it is L by root 3 only. This distance is how much? L by root 3. I am writing the this relation. I can take this as, observe this carefully, I can take this as like this. A small triangle is this is removed part. With removed part I can take the our main point O is this. Everywhere I am writing main point O is this. Okay, about that point I am calculating. About point O, you can write the distance is equal to how much? L by root 3. This is like this, 3 triangles are there. Triangle 1, triangle 2 for triangle 3. So this can be written as 3 times the I dash. What is I dash here? I dash is moment of inertia of fractal triangle about O. Okay, this 3I dash value is equal to 12 into I. If I write this value, I dash is equal to how much? 4I. Again, I am going to use the parallel axis theorem. Now I am going to calculate that what is the moment of inertia of this fractal object about this point. You are going to see now. You can observe that about this point d is equal to L divided by the root 3. I can write from the parallel axis theorem, moment of inertia about point O, I dash is equal to I plus, I means this fractal object, plus m into L divided by the root 3 whole square. My I dash value is 4I. I can write the 4I, I plus m into L square divided by the 3. I can get the values 3I is equal to ml square divided by the 3. Finally, I will get the I value is equal to ml square divided by the 9. This is my answer. The moment of inertia of this fractal triangle about the center point O is ml square divided by the 9. This is the answer. And one more thing, 3 by 16 about this triangle is 3 by 16 times the ml square. 3 ml square. Now I wrote A everywhere. You can check that I from L to A made. If you want, you can take the value is 3 ml square divided by the 16. Okay, and first one is ml square by 8 is rod. I hope you have understand this one. I have taken this one from the David Morin book, classical mechanics is from that book I have taken. Thank you very much.